Hi, are you planning to deploy Deepseek on Amazon EKS with an optimal architecture? Yes, we are going to deploy Deepseek VLLM on Amazon EKS auto mode using GPU and inferential instances. Let's get started.
In this module, we will learn how to build container image for Deepseek VLLM for GPU. Let's get started.
Hi all, in this lab, let us understand how to run Deepseek model on Amazon EKS. Okay, now let's go to the inference workload section and let's go to the GPU and select Deepseek R1. Okay, the first one is about creating the cluster, but we have already created the cluster in the earlier lab, so let us skip this part. Okay, so instead we'll just set the context for the cluster. So I've already said this, I'll ignoring this. Second one is about creating the container image for DeepSeek on GPU. So here what we will be doing is I'll first log into the ECR. Okay, so and we will just pull one open source image and tag it and push to ECR. Okay, so we are not really building any image from the scratch. Instead we'll be using the public image. I'm only pushing that to my ECR repo so that it is easy for me to access because it's ECR. So instead of going to the internet, I just wanted to use it from the ECR so that tomorrow if you wanted to create a VPC link to the ECR, it will be faster and secure. Okay, so that's what I'm doing. So let's run through the instructions. So I copied the command. This is my VS Code environment. I'm just running the command to log into my ECR repo. So it is succeeded. And second step is basically getting the ECR repo URL from the Terraform output and keeping that value in the environment variable. So I've already run this command earlier. So let me just do echo and check whether the value is proper or not. Okay. So here I simply run the echo command. So I see that the ECR repo image name is already set. Okay. Now I'll be pulling this image from the public internet. Okay, it is hosted in vllm/vllm-openai. So let me run this command. So I've already pulled this image in the past, so it's already there, so it's faster. Otherwise it will take few minutes because it's a very large size. So next I will run docker tag and docker push. Both commands I'll copy and run at once. So the image is also pushed to the ECR. Now let us go to the ECR repo and see how the image looks like. This is my ECR repo for Deepseek VLLM GPU. So as you see, the size is 9 GB, which is quite huge. So it's a private repo, and this is the namespace, and this is the URI, complete name of the repo. Okay. So we finished this step. The next one is deploying the Deepseek R1 VLLM on GPU. Okay.
In this module, we will learn how to deploy Deepseek VLLM model on GPU. Let's get started.
So first we have to create the namespace. I've already created this step, so I'll skip this. Next, I have to deploy the manifest files. So let me go to this folder. So inside this folder, there are two files, GPU and service. Okay, so let me open this and show you how the configuration looks like. So this is the folder where you can see the Deepseek VLM GPU deploy and the service file. So this is a folder where you will see two files. One is the deployment specification, another one is the service specification. So let me open the deployment specification. So you see the typical Kubernetes deployment. The name of the deployment is this Deepseek VLLM GPU, and the container is VLLM serve. So this is the command. This is for the GPU, and for the Neuron it will change. And this is the image. So I can use the ECR image that I've just pushed, or I can use the public image, either way is fine. So one thing we have to keep in mind is the initial delay is 1800 seconds. Okay, this is very important to understand. So 1800 is basically 30 minutes, which is a very long time because it takes that much of time for the container to be ready for the health check. So that much of time we have to wait. So the remaining configuration is straightforward. This is the path for the health check. These are the ports. This is the frequency of various checks. And readiness probe is also same. Both the liveness and the readiness probes initial delay is set to 30 minutes. Okay, this is something we have to keep in mind. The resources section, GPU is 1, okay, both the request and limits, and the CPU is 32 in the limits and the request is 16. Memory is same 100 GB. Okay, so according to this specification, Carpenter will bring the right sized EC2 machine which is having all of these resources. Okay, so there are two value modes. One is the cache value, another is the shared memory. So you see the specification in a while. So here, so this is the cache value, and this is the empty directory 2 GB, which is the memory based value, right? So the toleration is basically nvidia.com/GPU because we wanted to ensure that the pod tolerates on the GPU nodes, right? Because we have provided that as a part of the node pool creation. So this is the deployment specification, and the service specification is also very straightforward. So it will use the ports and it is a cluster IP service. Now both of them are deployed in the Deepseek namespace. Now let's go ahead and deploy these two resources in the cluster. So let me apply this. Okay, let me apply the service also. Okay, apply hyphen. Okay, service is also created. So the replica I have set it to 1. Previously it was 0. Okay, for testing purpose I made it 0, but now I set it to 1. Now let us see the pods which should be in the pending state. Get pod -a. Yeah, the pod will be in the pending state. So I am running the get node claim in a watch state. So you see G6.8x large machine just now created from accelerated BR GPU. It's on demand and it selected this AZ and it's not yet ready, and the node is just getting ready. Yeah, as a matter of fact, it's just taking few seconds to ready. Okay, that fast corporate it is. And if I put a watch on the pod in this particular namespace, right? So you will see the pod getting scheduled onto the node. Yeah. We have to keep in mind the time it takes to download will be significant because it is a very large image like we saw earlier, 9 GB. So we have to wait for a few minutes. So I'll pause for a few minutes until the pod into the running state. Okay. So if you see the node is ready now. Okay. Node claim is saying the node is ready, and the node is ready. The pod should be it's running. Basically it is still pulling the container image. If you wanted to see, let me do a describe pod also. So if you see, the pod is now in the running state, so it will take at least 30 minutes or so to ensure that all the health checks are passing and it's ready to serve the traffic. So we have to wait until that time. Okay. So we have already completed these steps. Okay. So we saw the node pools, node claim, we saw the node is created. We saw the node is also joined the cluster and the pod is in the running state. So what we will be doing is let us run this command just to see how the service definition looks like. Okay. Okay, this is a cluster IP service. Okay, so I can do the describe service as well. So you see there is one endpoint where the pod is now in a running state. Okay. Okay, so while the pod is getting ready, so what we can do is we'll go to the Neuron based deployment and deploy the Deepseek there. Okay, so that we can save some time.
In this module, we will learn how to build container image for Deepseek VLLM on Neuron. Let's get started.
So in the case of Neuron, so what we will be doing is we'll creating a container image for Deepseek and Neuron. Okay, so we'll follow the same steps. Okay, so we'll go to the VS Code server and log into the ECR and then build the image. Okay, so let's follow these instructions. So okay, so looks like there's an internet issue. uh, 1 second, I think this variable is not set up. Okay, so it is successful now. We're able to log into the ECR. Now let us run the remaining commands. So like earlier, we need to know the URL of the Neuron ECR repo. So it is from the Terraform outputs. I have already run this command. So let me see whether this variable is holding the right value. So it is in fact holding the right value. So that is the Deepseek VLM Neuron. So to build the image, so we have to clone this particular repo, and inside that there is a Docker file. So I've already done that. So let me go to the VLLM folder onto the directory. So I'm inside this VLLM folder, and inside that there is a Docker folder. Okay. So this is where there is a Docker file dot Neuron. Okay. So if I wanted to see how this file looks like, so let me just do a cat. Okay. Docker file dot Neuron. So this is the Docker file to build the VLM for uh, Neuron. So if you see, this is the public image, and a lot of commands we are running to install few packages. Okay, so you can go through this, and finally we are just running this command, right? And most importantly, we have to understand that a lot of Neuron specific packages we are deploying, the Python packages and libraries. So next I'll be building this image locally. So the image is built already. So I would run the command in the past, so it is a bit faster. So now I will run the Docker tag and the push commands at the same time. So the image is also pushed to the ECR. Now let's go to the ECR console and check how this looks like. So this is the ECR repo for the Deepseek VLM Neuron. So you see the size is basically 5 GB, which is also quite huge comparatively. So let's go ahead and deploy the model now. So we finished this part. Now let's go ahead and deploy Deepseek R1 VLM on Neuron. Okay.
In this module, we will learn how to deploy Deepseek VLLM model on Neuron. Let's get started.
The namespace is created already. So let's go to this folder. So I'm inside this folder, and you see there are two files, Neuron deploy Neuron service. So this folder contains two files. Okay, one is the deployment, one is the service file. Now let me show you the deployment file. So I'll put the replica as one, and important thing is the command, right? VLLM service Deepseek, and this is the model name, and these are the various Neuron specific parameters. So here the initial delay is also same as earlier for GPU, right? 30 minutes. Both the liveness probe and the readiness probe delays are 30 minutes. And the resource section, if you see, the Neuron core is only 1 and CPU limits is 30, request is 30, memory is 64 GB in both cases, and the value mounts are also same. And if you see, there is a toleration also, you should be able to see for this. So let me check the template file for the toleration that will be applied automatically here. Toleration is already here. So if you go back to the file and see, there is a toleration which is for the Neuron, aws.amazon.com/neuron. It is under the volume section. So now let's go ahead and deploy this YAML file. So let me copy this, deploy, copy this command rather. Okay. So it is created. If I go back to the service file, let me copy the service file as well and deploy. Now let us look at the node pools. Okay. Is there any new node getting launched because of this? I'll put a watch at the node pool, and uh, there'll be a watch on the pod as well. Okay. So if you see that the Neuron pod is created, it's just pending. And if you see the node pools, just one more node is just created. Okay, so as a part of this, let me run the node claim also, put a watch on that. So you will see what is the kind of instance that is getting launched by the carpenter. So this is infi inf2.8x large on demand, and it's true. Okay, a few seconds back. So that means the pod also should be running. Yes, it's pulling the image, which will take a while, and the node also should be ready now. If I see get node, you will see the two nodes, one for the GPU, one for the Neuron. Okay. So while the pods are in the running state, so what we will be doing is, let's go back to the instructions and deploy the Gridio UI as well to save time.
In this module, we will learn how to chat with Deepseek using curl command. Let's get started.
In this module, let us chat with the Deepseek model using the proxy UI. So for that, I'll run the port forward command, which is opening a local port on the host machine. So let me copy this command on my terminal. Okay, so there is a port open locally on the machine, which is 8080. Okay, I mean 8000 port. Let me make some calls. So here I'm making a curl request to the local host at this particular port, and it is basically sending a request to the chart. Uh, Basically, it's sending a request to the Deepseek model, right? So let me copy this command and make a request. So I just pasted this command. So let us see if it's going to send some response. This may take a while. It may take a couple of minutes or so for the first response. Okay, so let us wait for some time. I'll pause the video. So the response has come from the DeepSeek model. If you see the response, so I just asked a simple prompt, what is Kubernetes, right? So this is a JSON response coming from the model. So this is how you can verify testing with the DeepSeek model using the curl command from the local terminal. Okay, so this concludes the module. So what we will do is, we will do the similar testing for the neuron based model as well. Okay, so we will do the same thing. We'll just open the port for the service. Okay, so I'll just go here and I'll just disconnect the previous one. Okay, Now I'll just run the port forward command again. This time I'm running the command for the service, which is basically pointing to the Neuron based deployment. Okay. So I will do the same command again. I'll just send the command again to the same proxy server and wait for some time. So we got the response back from the Deepseek model for the curl command. So it may take a while, but yeah, we got the response. So this is how you can verify using the proxy UI. Okay.